Hi my dear students, last class we finished sources of sound and vibrating parts in different sources of sound. So today we can study the propagation of sound waves. The word propagation, that's a new term for you. Do you know the meaning of propagation? Propagation means traveling. So propagation of sound means traveling of sound. Do you know how sound waves are propagating? Sound is traveling in the form of waves. But we don't know what is a wave. That we have to study first. We already studied sound is produced by vibrations. Vibration is an oscillation in which one end of the object is fixed. So, if we are considering this particle, how it will vibrate? Like this, to and fro motion. Same way, if we are considering an oscillation, this will be the resting position or mean position of the object. First, it will go to this line. So, how we can represent the motion of this object as a wave? First, the object will be at rest. That we can represent by a straight line. We already studied sound is produced by vibration. Vibration means to and fro motion. So here, how we can represent the vibration as a wave? First, the object will be at rest. If this is the vibrating particle, this is the resting position of that object. That we can represent by this straight line. Next, what this object will do? It will vibrate to one side. So here also the object will vibrate. Again, this object will come back to its original position or mean position or rest position. That means here. Now again it came back to our straight line, that means resting position. Next, the object will move to opposite side. Here the object will come to this side. It will not stop there. The object will come back to its original position or mean position or rest position. So in this wave also it will come back to its original position, that is straight line. It will not stop there, it will continue so and so. Oscillations, many oscillations are there, many vibrations are there. Here also many waves are there. This we are calling one wave. Starting from here, finishing at this point, this one we are calling one wave. Sound is propagating or traveling in form of waves. One more important point, sound needs a medium for propagation. What is the meaning of medium? Consider a classroom. Teacher is speaking and students are listening. So through which substance sound is traveling? Air is the medium there. So the substance through which sound travels, that we are calling medium. So wherever sound is there, for its propagation there should be a medium. If you are considering space or in moon, there is no medium because there is no atmosphere. So when two persons are talking to each other, others can't hear. Why? There is no medium or no atmosphere in moon. Using some other devices, they can communicate. Next, there is an experiment in your textbook that proves the need of medium for the propagation of sound. There is a video, just watch it. Now all of you watched the video. From that you understood sound requires a medium for its propagation. Next, we have to study the type of waves. There are two types of waves, longitudinal and transverse wave. Among that, sound is a longitudinal wave. But we don't know what is longitudinal wave. Longitudinal wave means in that the particle vibrates in the same direction of propagation of wave. Suppose the sound is propagating in this direction, the particle also will vibrate in the same direction, means the particle will move to this side first, then come back to its original position and also go to another side. Here the direction of vibration of particle and the direction of propagation of sound are in the same direction. That means longitudinal wave is a wave in which particle vibrates in the same direction of propagation of wave. One more thing, if it is a longitudinal wave, this part we will call compression. C-O-M-P-R-E-S-S-I-O-N, compression. This part we will call rarefaction. So, another definition for longitudinal wave is one compression and rarefaction will form a longitudinal wave, or longitudinal wave propagates in the form of compressions and rarefactions. Next, we have to study terms related to a wave. 4 terms we have to study. First term, amplitude. What is meant by amplitude? If you are considering the oscillation of a particle, this is the main position. First, the particle will go to this side. There it will cover maximum distance. So, the maximum displacement of an object from mean position is called amplitude. amplitude is represented by the letter small a. So this is the amplitude. Then it will come back to its original position and will go to opposite side. So this is also amplitude. How we can represent it in a wave? In a wave, this is the amplitude, because this straight line is the mean position or rest position. From that, how much distance the object covers, that is amplitude. So what is the definition of amplitude? Amplitude is the maximum displacement of an object on either side from its mean position. It's easy for you if you are writing the points in your physics notebook. What about the unit of amplitude? It's only a length. Do you know the SI unit of length? Meter. So here meter is the unit of amplitude. Next term, wavelength. Wavelength is represented by the symbol or letter lambda. Listen here how to write it like this. This we are calling lambda. What will be the definition of wavelength? From this name itself we can understand the length of a wave. Wavelength is the length of a wave. In a wave, how we can represent wavelength? A wave that starts from here, then ends at here. So what will be the complete length of this one? That we are calling wavelength. There are so many ways for representing wavelength. Already we studied longitudinal wave propagates in the form of compressions and rarefactions. So wavelength has another definition, one compression plus one rarefaction. One compression plus one rarefaction means wavelength. Some more ways are there for representing wavelength in a wave. Starting from here. Then half wave will finish here. Full wave will be at this point. This one also we are calling what? Wavelength. Same way here also you can represent. Then the half wave will be at this point. This point the wave will finish. Then another definition for wavelength is the distance between two consecutive compressions, or the distance between two adjacent compressions, or the distance between two consecutive rarefactions. So there are four definitions for wavelength. Wavelength means length of a wave, or one compression plus one rarefaction, or the distance between two consecutive compressions, or the distance between two consecutive rarefactions. Also you should know the way to represent wavelength in a wave. So here it's like a graph. So which quantities we are plotting on x and y axis? You already know this is our x axis. So here we are plotting wavelength. What is the unit of wavelength? Meter. Because it's a length. SI unit of length is meter. And y-axis, which quantity we are plotting? Here the amplitude, that means displacement. That also in meter. So this we can call as the displacement distance graph also. Wavelength means distance, so this we can call as displacement distance graph. Which is the third term related to a wave? Time period. It is represented by capital T. What will be the unit of time period? It's a time. So second. Can you tell what will be time period? Time for completing one vibration, or time for completing one oscillation, or time for completing one wave. That is time period. How we can represent in a graph? Here on x-axis we are plotting time. On y-axis the same quantity, displacement in meter. So we know that time period is the time for completing one wave. So one wave started from here and ends at this point. What will be the time for that? So here the time period also you can mark in several ways. One wave you can take from starting from here, then it will finish at here. This way also we can represent time period. Fourth term, frequency. Frequency is represented by two letters. There are two symbols for frequency, small f and small n. In normal life we are using the word frequently. Here frequency means the number of oscillations completed in 1 second, or the number of vibrations completed in 1 second, or the number of waves completed in 1 second. 1 second means unit time. Unit means 1. So we can write the definitions in that way also. Frequency is the number of oscillations completed in unit time. That we cannot represent in a way. So we have to study only the definition. What about the unit of frequency? Hertz. Heinrich Hertz, that is the name of a scientist. So Hertz is the unit of frequency. Short form is capital H small z. Next, the relation between time period and frequency. We can draw the waves and from that we can derive this relation. Consider two waves. In this wave, in 1 second, one wave completed. So frequency will be what? Frequency is the number of waves completed in 1 second. What about the second wave? Here in 1 second, half of the wave only completed. Here in 1 second, half of the wave only completed. That means frequency is equal to 1 by 2, that is 0.5 Hertz. Okay, then consider the time period. Time period means time for completing one oscillation. So here the time for completing one wave is 1 second. For second wave, time for completing one wave is 2 seconds. Just compare the two waves. Here frequency decreases 1 to 0.5. 0.5 is less than 1. Frequency decreases but time period increases. That means T time period is inversely proportional to frequency. When time period increases, frequency decreases. When time period decreases, frequency increases. So T is equal to 1 by F. That is the relation between time period and frequency. This equation you can write it in another way also. F is equal to 1 by T. Any one equation you have to study. One more relation is there in your textbook in the box. Do you know speed of the wave V is equal to frequency into wavelength. Using the symbols, how we can write it? V is equal to F lambda. So that also you have to study. Next we can study different types of sound on the basis of frequency. On the basis of frequency, sound is classified into 3 types. They are, first one, audible sound. One more name for this, sonic sound. Do you know the meaning of audible? Audible means the sound that is able to hear. Here the audible sound means the sound that can be heard by human beings. The range of audible sound is 20 Hz to 20,000 Hz. Here 20,000 Hz means 20 kilohertz. Already you know that 1 kilometer means 1000 meter, 1 kilogram 1000 gram. Like that 1 kilohertz means 1000 Hz. So in this audible sound, only one sentence you have to study. The audible sound is in the range of 20 to 20,000 Hz or 20 Hz to 20 kilohertz. That is the audible sound range for normal human beings. Actually, infants, they can hear up to 35,000 Hz, and also old people, they cannot hear up to 20,000 also. There will be variation. They can hear only up to 12,000 Hz only. But we don't want to study that details. Only for normal human beings we are considering, that is 20 to 20,000 Hz. Next one is infrasonic. Infrasonic means below this sonic sound, below this audible sound. That means less than 20 Hz. You already studied in maths, less than, greater than. So less than 20 Hz, if that is the frequency of a sound, that sound we can call as infrasonic sound. That is not audible to human beings. The third category is ultrasonic. What will be its range? Greater than sonic sound. Greater than 20 kilohertz. This ultrasonic sound is audible to bats, dogs, elephants, etc. And one more thing we have to study under ultrasonic sound, how bats are using this. During night, when bats are traveling, if there are any obstacles in their path, they can detect the obstacles using ultrasonic sound. Bats are using this ultrasonic sound for detecting the obstacles in their path. How it will be? Bats will produce ultrasonic sound and they will hit that obstacles and then return to the bat. From that, bats can understand that something is there in my path, and also they can calculate the distance between that obstacle and bats. So what all things we studied in today's class? How sound is propagating. Sound propagates in the form of waves, especially longitudinal waves. Also, sound needs a medium for propagation. Longitudinal wave propagates in the form of compressions and rarefactions. Also, we studied the terms related to wave: amplitude, definition, unit, simple, wavelength, time period, frequency. Next, we studied the relation between time period and frequency. One more relation: speed is equal to frequency into wavelength. Next, classification of sound on the basis of frequency: audible, infrasonic and ultrasonic. How bats are using ultrasonic sound. So all of you should write these points in your physics notebook. Okay, thank you. Have a nice day.